Okay, so welcome back. And so now we're going to start discussing arc length. Since we've already know how to find arc length, right? We have the formula, and it's given by S equals R times theta. So let's just jump in doing some examples. Okay, so in this example here, it says, assume the orbit of Mercury around the sun is a perfect circle. Okay. Mercury is approximately 36 million miles from the sun. Okay, so it orbits around the sun and it's approximately 36 million miles away from the sun. So that's the radius, right? So A says, in one Earth day, Mercury completes 0.0114 of its total revolution. Okay? So in one 24-hour period, so on one revolution of the Earth, Mercury makes 0.0114 of its total revolution. How many miles does it travel in one day? Great. Well, the 0.0114 is the fraction of its total revolution. Right? So 0.0114. 0.0114 represents what? The proportion of Mercury's revolution around the sun. Okay. Or its orbit, right? So what's the circumference of Mercury's orbit? Let's start with that, right? So we know, because if we know the entire orbit, right, we know the circumference, then we can figure out the arc length from there. So the circumference equals 2 pi r, which is the same as what? 2 pi times 36 million. Okay, and so this is going to be in miles. So if we put this in our calculator, we come up with approximately 226 million miles. Okay, so far so good. Now, we know that this is the proportion. This is the proportion of Mercury's revolution that it's completed so far. Okay? Okay? Now, that means all we have to do is this is the fraction of its orbit that it's completed. So it's only completed this fraction of the complete 226 million miles. So all we have to do is multiply this, because if we want to represent this as a percentage, right, this would be basically saying that Mercury's completed 1.14% of its orbit. So this is a fraction, right? This is the fractional amount, or the fractional part, right, of its total orbit. So in that case, all we have to do is multiply, right? So let's do it. So it's going to be S equals 0.0114 times 226 million. Okay, and if we put that in our calculator, we get approximately 2.58 million miles. Oh, 2.58 million miles. Okay? Okay, so that's the first part. Now, part B says convert it to radians. Okay, well, guess what? To convert it to radians, we're going to use our formula here, because we know that the angle measured in radians is the ratio of the arc length to the radius. We've got the radius and we've got the arc length. So, to find the angle, the radian measure of the angle, it's going to be S over R, which is going to be, where is it, 36,000, or no, 2.58 million miles. This is in millions, right? So I'm just going to drop the magnitude. So it's going to be 2.58 million miles divided by 36 million miles. And so if I divide those two, now it's going to give me a unitless number. The millions are going to cancel out, right? And so it's going to become 0.0717 because the magnitudes are going to cancel too. So in essence, it's going to be 2.58 divided by 36, and it's going to give me 0.717. Is that right? Oh, I'm sorry, 0.717. And that is the radian measure of its angle of rotation. All right, that's it. Have a great day.